Very good afternoon, children. Today I will be starting with certain laws of logic and what is the application of logic in switching circuits. Okay, let's start. So let us go with the laws from easy to difficult. So very first law is commutative law. What do you mean by commutative law? Commutative law says, like in our addition we say a plus b is equal to b plus a. Similarly here P or Q is equal to Q or P. Yes, I can change the order for the OR combination as well as AND combination. That is, P and Q can be written as Q and P. This law is called as commutative law. Okay. Now, associative law. Like in mathematics, we have studied 2 plus 3 plus 5. If I do 2 plus 3, then I add with 5. Or if I do 3 plus 5 and then I add 2, I get the answer same. Same way here. First I am doing P or Q, then I am doing OR with R, which is same as first I am doing Q or R, then doing OR with P. If the signs are same, I can change the brackets. This is called as associative law. So let's move on to the next law, that is complement law. Now what do you mean by complement law? Complement law says that P or negation P will always be true. How it is possible? We know that if P is true, negation P has to be false, and if P is false, negation P has to be true. So never it will happen that both of them becomes false. Either or one will be true. So in OR combination, if any one of them is true, the answer is true. So P or negation P is always true. At the same time, P and negation P will always be false, because if P is true, negation P is false. If P is false, negation P is true. That is, at the same time, one of them has to be false. So in AND combination, if any one is false, the answer is false. So these two laws are called as complement law. Next we have conditional law. Now what do you mean by conditional law? We have learned P implies Q. In P implies Q, we have if and then keyword. But if I want to write a statement of if and then without using if and then I will replace this P implies Q by negation P or Q. How to justify this? You draw the truth table of P implies Q and you draw the truth table of negation P or Q. Both will be identical. So P implies Q can also be written as negation P or Q. So in exam there can be a question, write the implication statement without using if then. So this is the only possible way you have to write. Okay. De Morgan's law we have already studied, that is negation of P or Q is equivalent to negation P and negation Q. Negation of P and Q is equivalent to negation P or negation Q. Okay. Now let us learn first idempotent law. Now what does it say is that for OR combination, it is for P or P, the answer remains P. Why? Because P is true, it will be true or true. That is true. If P is false, it will be false or false. It will be false. So the answer depends on the value of P. So P or P will be P. At the same time, P and P will also be P, because again the answer depends on the value of P. Now the very important law which you'll be using many times in your sums, that is distributive law. What does distributive law says that in mathematics we have studied A into B plus C becomes AB plus AC, that is A gets multiplied. Similarly here it is P or Q and R. Outside there is OR, inside there is AND. So this P and OR gets multiplied inside. So what I will get? P or Q. You can see here P or Q. Then I'll place AND over here. Then P or R. That is P or R. Either this combination will be given or this combination. So if you see the RHS part over here, what is common thing over here? P is common, or is common. So what I can do? I can take P or common. So what is left here? Q and R. Same way I can apply distributive law to this bracket also. It is P and Q or R. So it becomes P and Q or P and R. You can see here P and Q or P and R. Again, if I take P common and common, I get Q or R. So in sums, while solving, if you get such two brackets, think of taking common. If you see this bracket, one is and one is or, think about opening the bracket. I hope you all are getting it. So we started with idempotent law, commutative law, associative law, distributive law, De Morgan's law, conditional law, and complement law. Children, you have to remember the names. The names are very, very important because while writing justification, you have to write these names and not these laws, because you have to apply these laws and write these names. Okay. One sum can be asked in an exam for 4 marks, and practical it can be asked for 5 marks. We write P as the switch S1 is closed, Q as the switch S2 is closed, and L indicates that the lamp is on. P, S1 is closed, Q, S2 is closed, and L, the lamp is on. Okay, so series combination is represented by and, parallel combination is represented by or. Okay, very important sum for exam. Without using truth tables, show that P and Q or negation P is logically equivalent to P and Q. Here the very important statement, without using truth tables. So I'll take LHS and I'll try to bring RHS with the rules of logic which you have learned right now. I'll take the LHS. Now see, you can see one bracket is there with one and combination and one or combination. So what will I do? I'll apply distributive law, that is I'll multiply this inside. So what will I get? P and Q or P and negation P. It's P and Q or P and negation P. Now we know that P and negation P, they both cannot be true at the same time. If one is true, other is false. So true and false will give me always the answer as false. It means this combination will always represent the answer as false by complement law. See, this P and negation P becomes false. So what is left? P and Q or false. This is my one bracket. Let us assume this as A. So A or F. Now if this A or F, here one of the thing is false. So if this bracket becomes true, the answer should be true. If this bracket becomes false, the answer should be false. So here the entire answer is depending upon this bracket, that is something or F is something. That is your answer. This is called as identity law. I forgot to explain the identity law. The law says that something or F is something. So your P and Q or F is called as P and Q. So our statement has been proved. Okay, one more law you should remember. P double implies Q is nothing but P implies Q and Q implies P. This is also one more law. P double implies Q is logically equivalent to P implies Q and Q implies P. See, here mentioning law's name is very, very important. Otherwise, you will not get marks. Okay. Next sum, P and Q or negation P and Q or negation Q and R. Now there are several brackets. So very first thing is I'll try to take something common. First I'll take my LHS. You can see the first two brackets. What is common over here? Q is common and is common. What is common? Q is common and is common. First I'll apply commutative law so that I can reverse these two brackets. And I can apply distributive law. So what I'll take? Q I'll take common and I will take common. So what is left? P or negation P. What is left? P or negation P and Q or negation Q and R. Now P or negation P. Again one will be true, so other will be false. If this is false, this is true. In both the cases the answer comes out to be true, because one of them will always be true, other will be false. In OR combination, if one of them is true, the answer is true. So this bracket gives you the answer as true. See, true and Q or negation Q and R. Now true and something. Now this something will depend on something only, because if Q is true, the answer will be true. If Q is false, the answer will be false. So the answer of this bracket depends on Q. So answer will be Q by which law? Identity law. See, Q or negation Q and R. Now see, again I'm getting one OR bracket and one AND bracket. I'll apply distributive law. So I get Q or negation Q and Q or R. What is Q or negation Q? True, because in OR combination, one of them will be true. So answer always will be true. So I got true and Q or R. Now true and something is something by identity law. So I got my answer Q or R. Can you see how to write the laws and how to justify answer? Let's move to the next part of this topic. Represent circuit symbolically and draw input-output table. Now what is input-output table? I'll show you. Okay, this is the diagram given to you. You have to represent symbolically in logic form. So first I'll describe the switches. I have S1, S2, S1 dash, S2 dash. So S1 is represented by P, S2 is represented by Q. At the same time, S1 dash means negation P, S2 dash means negation Q. No need to name them a new switch. We'll name them as negation P and negation Q. Now if you observe, these two are parallel among themselves and these two are series. So what should be the answer? P or Q. This should be P or Q and this should be negation P and negation Q. Again both are parallel. So let's see the answer. So see, this is my first, that is P or Q. Then down one was in series, that is negation P and negation Q, and both were in parallel. So we have OR combination. Now I want to draw input-output table. That means you have to draw truth table. But while drawing switch table for switch circuits, we represent true by 1 and false by 0. Remember, we don't show it by true false. We show it by 1 and 0. See, I've drawn the truth table over here. You can go through it. So here the answer is always 1. So it is a tautology. Let's take another example of switch. Now see, these two are in series. These two are in series. Then these two boxes in parallel. Then whole box is in series with S3. So let's solve orally first. It should be P and Q or negation P and negation Q and R. There is a new switch S3, so I'll name it as R. So see, P and Q, negation P and negation Q, or with them, this is one box, so I can represent by a square bracket, and R. Again I have to draw a switching table, so I've drawn the table. It was very long name, so it is represented by another name L, so I can use L and R also. This way also I can write. Remember, the switching table has to be drawn in one proper table. You cannot divide the table into two parts. Okay.